Okay, decimal applications. Guys, pay attention because there's a problem that I'm going to omit in this section, which we normally do, but I'm going to omit it. So it means it will not be worked in class. You'll skip it in the homework and in the review, and more importantly, on the quiz and test. We're familiar with the term average. In 2022, the average family has 1.94 kids, okay? In Georgia, the average household has 1.86 cars in 2019, okay? We have to think about it. Actually, nobody has 1.94 kids, and nobody has 1.86 cars. So what happens is we're taking integer numbers. Some people have fewer than one car, some people have more than one cars, and we average them together, we get a 1.86. So it just tells us this is sort of the center, okay, of the data set. So an average is a way of finding the center. You're most familiar with average when it comes to your grades, okay? So we add up your grades, divide by the total number you have, and that's the average. Your average could be at 80, and you never made an 80 in this class, but you made more than 80 and less than 80, okay? The average number of students in the private school in the United States is 150.9. What does that mean if you think about this? If the average private school has this many students, what can we conclude about Woodward? Well, I mean, we've got over 2,000 students. That means we are a very large private school. That means there are a lot of schools that are less than 150 if the average turns out to be that. Look at this, and the average retirement age in the United States. So if you look at the state of Georgia right here, and you think about your teacher, next month, there is your teacher. So I am the average retirement age, okay, in the state of Georgia. Or if I look at Georgia, yes, I'm the average of when someone retired. How do you think we get this information? I mean, how do we get the average retirement age, okay? Typically, a lot of the times you see data, it's the result of some kind of survey or questionnaire, okay? So what if I were to, gather the data? There are whole classes that talk about a science behind that, because if I wanted to ask, people who are retiring, what if I just sat on Main Street in College Park and anybody walked by, ask them when they're going to retire, or if they retired, what age? Would that be a good way of representing Georgia? Probably not, because that's just Atlanta. But even so, that doesn't represent what might be going on in, say, Alpharetta or Buckhead or other areas. So you want to have some diversity. Or what if I only ask women when they retire? Would that not quite right, because women have a longer life expectancy? Or if I only ask men or only people of a certain color? So a lot of times there'll be classes that talk about the science behind getting an unbiased or random sample. Okay. Now, we've talked about average before. The average, another word for that is the mean or the arithmetic mean, all refer to the same measure. It's a measure of central tendency. Central tendency means I'm trying to describe the middle of the data set. It's the sum of all the items divided by the number of items. So you know that. The mean is the average, the sum divided by the total items. So let's look at this. I've got 4 test scores. Let's find the mean. So I need to add up all of these scores. So 86, 82, 93, and 75. So when I add these up, 5 plus 3 is 8, plus 8 is 16. So 9 plus 7 is 16, plus 8 is 24, plus 8 is 32, so 336. So the mean is going to be 336 divided by 4. So if I do that operation, 4 into 336, 4 goes into 33 8 times. That leaves me with a 16 and 84. So my average is 84. So if I look at where my average is, 60, 70, 80, right there at this line. So this is where 84 is. Is that a reasonable measure of the central tendency of this data set? So if you look at it, nobody made an 84. But if I look at 2 scores were above 84, 2 scores were below 84, it looks like most scores are fairly close to that line, with exception of that 75. So I feel like this is a reasonable data set, okay? Why? Most scores are close to 84. Let's look at another set of data. 46, 100, 190. Let's find the average. So 46, 100, 100, 90. Add those, you get 6, 3, 336. So it's going to be 336 over 4, which I just determined was 84. Now ask yourself, when I'm looking at this line of 84, is the mean a reasonable measure of this data set? Well, if you look at it, if I look at this, okay, the scores appear to be further away than the other one, okay? So I've got one, that first score is way off, okay? The other two are pretty far away. There's only one score that's close. So it's sort of a subjective question, but compared to this one, more of the data looks like it's close to the line, and this one, is this a reasonable? It doesn't look to be a reasonable representation of the data set because nobody made a B on this particular test, but yet the average is a B. So how many scores are lower than the mean? 1 score, and 3 scores are higher than the mean. Okay. So let's look at another example here. During a semester, students' grades are as follows. The GPA is the total point value of all credit hours divided by the number of credits. So for example, with an A, you get 3 credits. A B, you get, this is a class has how many hours credit, but with an A, you get 4 points. A B, you get 3, and so forth, okay? So what it means here is, like, if I make an A in math, that's 3 credit hours, okay? And an A earns me 4 points. So I'm going to get a total of 12 points. A B is going to earn me 3 points for a B. So 3 times 3 is 9. This next A is going to earn me a 4. 4 times 3 is 12. The C is going to earn me 2 points. 2 times 1 is 2. And the D is going to earn me 1 point. 1 times 2 is 2. So I've got what? The total number of points that I get. So 12 and 12 is 24, plus 4 is 28, plus 9 is 37. Okay. And then if I think of how many hours did I take? 3, 6, 9, 12. So in order to find my GPA, all I need to do is just divide 37 by 12. So 12 goes into 37. It goes into there 3 times. That leaves you with a 1. It doesn't go into 10. So 12 goes into 100. Is it 9? I think 8 times. So 8, that'd be 80 plus 16, 96. That leaves me a 4. 12 goes into 40. 3 times, 36. And that's a 4. So in this one, your GPA is 3.083. And that's how GPAs are calculated. It's just an average, okay? Now, we've noticed that in this previous example where I had these test scores, what was the biggest difference is in that second test score, I had a really, really low score, that 46. And that was enough to bring the average down. Or excuse me, the average stayed the same, but it made the average not really represent the data set, because look at this. These guys did really well. 3 of the people made A's, but yet my average is a B because of that 1 score. So an average can really penalize a data set. Let's look at a different measure of central tendency, the median. The median of a set of numbers is, if you put the numbers in numerical order, it's the number in the middle. So if I look at this, the smallest number is 9, and then a 10, and then a 12, and then a 13, and then 34, 43, and 81. So there are 1, 2, 3, 4, 5, 6, 7 numbers. So the middle of this data set is right there, okay? So you've got 3 numbers lower than that and 3 numbers that are higher than that. So the median is 13. So that's another measure of central tendency. It is the exact middle of the data set, okay? So it's a different measure than the mean. Let's find the median here. So let's line these up smallest to largest. So 12 is the smallest number, followed by 34, and then it looks like 74, and then 80, and then 87, and then 98, 100, and 102. Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8 numbers. So if I go to there, so 1, 2, 3, there is not a middle of the data set. There are 2 numbers in the middle. So when I have an even set, I can't find the middle of the data set. So the way I find the median is I average those 2 numbers in the middle. So that's going to be what? 167 over 2, which is going to be 83.5. Okay. So the median here is 83.5. So anytime you have an odd number of data elements, there will be a middle. If there's a middle, if there's an even number, you're going to have to average the 2 numbers. Now these are the test scores we saw a moment ago. We found the average was 84 in both places. Let's figure out what the median is. So if I line these scores up, 75, 82, 86, 93, even number, so the average of those is going to be the middle. So think about it this way, from 82 to 86, that's a distance of 4. So in the middle of that, it's just going to be half that distance too. So the median here is going to be 84. You look at the other data set, line these numbers up, 46, 90, 100, 100. The average of 90 and 100 is going to be 95, okay? So again, we had determined at first that the median was a really good measure for that first data set. The median was not a good measure of that second data set. Now, let's look at the median, okay? So if I look at the median for the first data set, so yes, that appears to be a good representation. The other one, the mean was 84, but the median was 95. There are more scores close to 95 than there are to 84. So it looked at, and then like I said, half the data is more than 95, half is below 95. So the median is a good measure here. The final measure of central tendency is something called the mode. It's just the number that occurs most frequently in a data set. So if I look at this data set, I see 4 occurring 3 times, okay? So the mode of this data set is 4. If I look at the next one, 1, 4, 3, 6, 9, 10, 14, 2, there's no number repeated. There is no mode in this data set, okay? If I look at the next one, let's see what I've got. I've got 3 9s, okay, but I also have 3 4s, okay? So in this one, the mode is 4 and 9, okay? So I can have multiple modes in a data set. Another way I can show you a data set is to show it to you something like this. Students were surveyed and asked how long it takes them to eat breakfast. What is the data set size? So like just count however many dots there are. We've got what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. So there were 40 students that got surveyed. What is the mode? What number occurs most frequently in this data set? I can see it pretty clearly. It's 10. What is the median of this data set? So the median is the number in the middle. So if I've got 40 numbers, okay? So if I've got 40 numbers, so you think about it, you've got 20 numbers and 20 numbers. There is no middle when I've got an even number. So what I'm going to do, I'm going to take the last number here and the first number here and average them together. So the 20th number and the 21st number. those are the numbers that I need to average to get the median. So what is the 20th and 21st number? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the 20th and the 21st number are both 5s. So the median is going to be 5. How do I find the average? Okay, I know it's a big number divided by 40. Okay, so if you think about this one, 1, 2, 3, 4, 5, 6 zeros. It would be like averaging 6 zeros. That's going to be 0. 1, so 2 of these, 2 times 1 is going to give me 2. 2 times 3 is 6. 3 times 5 is 15. 2 times 4 is 8. 1, 2, 3, 4, 5 times 5 is 25. And then 16, 27, 1, 2, 3, 4, 5, 6, 7, 70. 11 times 4, and 12. Okay. So 6, add these together. 2 plus 6 is 8, plus 15 is 23, plus 8 is 31, plus 25 is 56, plus 16 is 72, plus 27 is 99, plus 70 is 169, plus 44 is 3, 213, plus 12 is 225. So it should be 225 over 40, okay? Which is going to be, if I divide those guys by 5 to get smaller numbers, 5 goes into there, what, 4 times 45? 45 over 8. So 8 goes into 45. 8 goes into there 5 times. 8 goes into 50 6 times. 8 goes into 20 2 times. And 8 goes into 40 5 times. So the average is 5.625. In the same dataset survey, assume those who do not eat breakfast are omitted. So the people that took 0 minutes to eat breakfast, if those are gone, okay, what does that change? Well, the data set, that means I took out, what, 6 people? So 40 minus 6 is 34. The mode is still, what, 10? The median, so if I took away 6, my data set went from 40 minus 6 to having 34 elements. So 34, so 17 and 17. So it's going to be the 17th number and the 18th number. So if I figure that out, let's see if I count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18, okay? So it's the average of 5 and 8. So that's going to be, what, 6.5. So the median is 6.5. And then the mean, well, I don't have to do all this work again, because if I added all these numbers up and got 225, when you take the zeros out, that doesn't change anything. So it's just going to be 225 over 34. And I would probably take that as an answer here, since you're not using a calculator on a quiz, but you could certainly use a calculator on the test for that. Look at the example here. Sometimes it's often helpful, rather than what we did here, each dot represented a person that I surveyed. Sometimes it's helpful to group the data. So I look at this number of occurrences of people. I'm sitting in a coffee shop and I'm counting the number of cappuccinos that were made per hour, okay? So if I made 0 to 3 cappuccinos, that happened twice. 4 to 7 cappuccinos, that happened 3 times. 8 to 11, that happened 8 times. 12 to 15, and so forth. So I do not know, for example, in this red, I could have made 1 cappuccino, you know, or in this one, I could have made 5 or 6. I don't know what they are, but I've grouped the data. Sometimes it just makes it easier to see. So the horizontal axis are what? Cappuccinos. Cappuccinos per hour. And then the vertical axis is the number of occurrences. For how many total hours did the coffee shop gather data? Well, this one happened twice, 3 times, 8 times, 3 times, and 2 times. So 5 plus 8 is 13, plus 5, 18 hours. So it looks like I gathered data for a total of 18 hours. Okay. Now, number of cappuccinos, 0 to 3, that happened twice. Okay. So what it means is I could have made 0, 1, 2, or 3 cappuccinos. 4 to 7 happened 3 times. So it could have been that I made 4, 5, 6, or 7 cappuccinos. 8 to 11 happened 8 times. So I could have made 8, 9, 10, or 11. 12 to 15 happened 3 times and 2 times. So 12, 13, 14, 15, and 16, 17, 18, 19. Okay. Now, if I were to ask you to find the median, I can't line up all the scores, I mean the number of cappuccinos, because I don't know, I don't have the raw data. This would be the raw data, but it's been grouped, okay? But what I do know, if I look at, let's look at the number of occurrences of data elements here. So I've got what, 18 different data elements. So over 18 hours, I selected this. So how would I find the median if I had 18? So if I had 18 elements in my data set, so 18 different hours, that's even, right? So that means it's going to be what, the 9th and the 10th, the average of the 9th and the 10th. Okay, so let's look at it. When I'm sitting here, I've seen 2 data elements. Sitting here, I've seen 5 data elements. Okay, add 8, I've seen 13 data elements. Okay, so where do the 9th and 10th data element live? Well, the 9th is in here and the 10th is in here. So I don't know what they are, but I do know that after I've seen 13 different hours in this data set, that the 9th and the 10th have to live there. So all I know about the median, it has to be between 8 and 11. So the median has to be between 8 and 11 because it's the average of the 9th and 10th number, okay? Now, this is what we're skipping. Anywhere where it says to find the mean and the data has been grouped, we're going to skip this question, okay? So we will skip this question of averaging or finding the mean for group data, okay? It's just a concept that's a little bit too pushed for the time that we have, so I want to skip that. Let's find the median grade of what we see here. So if I look at this, the median grade, so how many elements are in that data set? So 37, 26, 20, 9, and 8. So 6 and 7 is 13. So 13 plus 17, that's going to be a 0 and carry a 3. All right. So 3 and 3 is 6 plus 4 is 10, so 100. Okay. So if I got 100 data elements, the 50 and the 51st, that's going to be where my median is. So here I've seen 37 data elements, so I've yet to see number 50 and 51. When you add 26 to that, so that's 63, that means that I know that number 50 and number 51 have to live in that particular area. So that means that this grade was, what was it? I covered it up. It was a D, okay? So it means that the 50th and the 51st element live in here, which means that my median grade is a D. So this is called a not good test grade distribution, okay? And last one here. We surveyed to find teachers and we recorded their ages. What is the median age for teacher? Estimate for the mean. Anytime you see estimate for the mean, we're not covering it from grouped data. Now, if I ask you to average 4 numbers, absolutely. But from grouped data like this, I'm not going to ask you to estimate the mean. So let's find the median. So let's just see, how many teachers am I talking about here? 10, 28, 32, 48, 50, 35, and 12. 8 and 2 is 10, 18, 18 plus 7 is 25. So 2, 3, 4, 5, 8, 12, 21, 215. So 215, so if I've got 215, if I divide that by 2, when you divide that by 2, 2 goes in there 1 time 107.5. So the way this data set looks, 107 and 107, that's 214. Then there's a number in the middle. The 108th number is in the middle of this data set. So the median is the 108th number. So here are the first 10 elements of the data set. I have yet to see the 108th number. When I get to here, I've seen 38 elements. Add the 32 and I get 70. I still haven't seen the 108th number. Add 40 to that and I get 118. So that means the 108th number has to live right here. I don't know what it is, but I know it's there.
Interruption. We have an announcement before the bell. Students who are in advanced orchestra will head to the cafeteria for just a few minutes before being released to class. Advanced orchestra will meet in the cafeteria. Our film students.
So what this means is the median age for a teacher, I can't get it exactly because I don't have the raw data, but I know that the median age is between 34 and 39.